What is that sweet, sweet noise? Oh yeah! It's electric! It's electric! I bet your parents know this song. Your homework for this weekend? Do the electric slide with your parents. Do some dancing. The electric slide. Electricity is so awesome, it has its own song. Two big questions to try and answer with this lesson. What actually is electricity, and why does electricity actually happen? I'm going to prove to you that electricity is like water going through a pipe, and I'm going to also prove to you electricity is also like a big mob on Black Friday. First question, what actually is electricity? What some people think, like they'll say, hey, electricity is an energy source, which is true, but that doesn't really tell us what electricity is. Some people, like you'd say, like gasoline. Well, gasoline, what's gasoline? It's an energy source. It's more than that. There's more to gasoline than it just being an energy source. You know, it's a fossil fuel, and there's a whole much more things we could say, hydrocarbons, whatever. So in terms of electricity, there's a whole much more things we can say about it as well, other than it's just an energy source. So let's take a look at here. A couple different things to look at, some different pictures. What is it? For middle school, the main thing that I want you to understand and really grasp onto, hang on to, is that electricity is the flow of electrons. That's the main thing that I want you to know. Electricity is the flow of electrons. What is electricity? Now let's learn a little bit more about that. So if we look at this atom here, this atom is actually copper, and we look at, so the protons and all that are in the inside, they just drop with one circle, and then we look at all these other dots. These are electrons. These are different electron shells. We'll talk about that later. Notice this outside shell only has one electron. It doesn't really like having this one. Copper is like, hey, I kind of feel lopsided, or I just don't like having just this one. So it really just wants to get rid of it. That's why copper is a good conductor. So now if we look at this, this would be like a wire. This would be like a wire. So let's shrink this down. Let's say that's all kinds of copper atoms. So inside of this wire will be like billions of these copper atoms that really, really want to give up this extra electron that they have. So what happens, so like here's a real life picture. So we got these copper wires and then the insulation. So this black here, the black would be the insulation, and then the atoms would be the copper. And again, there'd be like billions and trillions, I don't know, just crazy amount of copper atoms inside of here. And it wouldn't be just one ring of them, but for simplicity's sake, that's why we're looking at this. So again, these are copper atoms, and they have that one electron. So we're just looking at that one on the outside shell. It wants to get rid of that one. So here's an animation as to what that looks like. So if we check this out, imagine there's a like power source, something over here, and then there's something over here, like let's say a light bulb, something that wants to use that electricity. So these copper atoms, they don't lose that electron like permanently. What they do is they pass it down to their partner, and then that partner passes it down to the next partner, and that partner then passes it down to the next partner. So what they're doing is they're just shuffling. They're just like handing it. So they're always having one. They're just always sending that electron down the line. So to sum up, what actually is electricity? To put it very simply, electricity is the flow of electrons. And that flow then gives us energy. We can use that as an energy source. We can use that to power things, electric motors, light bulbs, whatever. Next big question, why does electricity actually happen? Why do these electrons get passed? What's causing them? Besides copper just having like an extra one that it wants to get rid of, why are those electrons being passed down a wire? Why does that happen? And the big reason why, which we know because you have some sort of experience with magnets, is that we know that opposite charges attract each other. So the positives are attracting the negatives. So if we look at this as like a picture of a battery here, is in the inside there's some sort of like a membrane that's keeping the positive elements from the negative ones. And what these negative ones want to do is they want to get around back over here. So that's basically how a battery works. Is these negatives, they're like super, super attracted. They want to get over here so bad. They're like, ah, let me over there. So then if we put a wire from here, we connect a wire to we connect the positive to the negative with a wire. Those electrons will flow through there. Now, we don't really want to actually do that with a battery because that'd create something called a short circuit. It'd get really hot. That would not be a good thing. But the positives would attract these electrons, and these electrons would just go right over there. It's similar to like a magnet, is that like the north pole of a magnet attracted to the south pole of a magnet. They stick together, versus positives and positives repel from each other. Here's another example of like why electricity happens, example in nature. If we think about lightning, which is really exciting, really powerful, inside of the clouds, or this picture is showing, hey, this is more of a negative type of charge here, or is it positive up here, and more of a negative, because molecules rub in and creating like a static charge. So it's kind of negative here, but then the ground, let's say, has a positive charge. So now there's a big difference. There's a big difference there. And the negatives are really attracted to the positive, so that then, bam, they get that lightning strike, and that lightning strike then evens it out. So the reason why this happens is really they attract each other, but they want to then even out. They don't like being so separated. They want to intermingle and then even themselves out. It's similar, kind of similar to the idea with biology. If you think of diffusion, osmosis, kind of similar to those concepts, is that. So here is my argument as to why electricity is like a mob on Black Friday. So imagine all these people, they want to get in this store, but they're blocked by the gates and the guards and all that kind of stuff. They're like all excited. Oh, I'm going to get my Christmas presents for like $5 cheaper. I'm so excited, whatever. So they want to get in here so bad. They're like the electrons. They want to flow inside of here. Now what I want you to think about, then what would be the protons, the positive charge? So if the people are the negative charge, they're the electrons, what inside the store would be the positive charge? Inside the store, the protons would be the products. So the products would be like those things that have the positive charges. Those products are attracting the people to the store. They want to get in so bad. As soon as that gate's released, people just run in, pushing people out of the way, and just running to get their products, like snatch it up. So like those products are attracting those people. So now it's your turn. Think about what else electricity is like.